Hello, welcome back. This video is dedicated to the time and work questions which were given in CAT from 1990 to 2014. However, the level of difficulty of those questions is very easy or easy. We have another video in which the level of difficulty of time and work questions is moderate. So, out of the 19 questions appeared in CAT 1919 to 2014, that is the last 25 years, 11 of them are easy, 3 of them are moderate, and the remaining 5 questions are very easy. So that's why I'm not solving all those 5 very easy questions. You must have solved all the questions that I'm going to discuss today. If you haven't, I suggest you to solve all the questions and then watch this video. You can check the link to download or to access the worksheet. Check the link of this link behind this video. Let's solve question number 1. A, B, and C individually can finish a work in 6, 8, and 15 hours respectively. They started the work together, and after completing the work, they got some amount in all. When they divide the money among themselves, A, B, C will respectively get. This is a very easy question. And that's why this has been given long time back in 2.5 decades back. So the amount we distribute should be based on the number of hours they work now. Since it's very easy to calculate their capacity, then this must be very easy question. Let's solve. Yeah, the capacity of A, you have no idea about efficiency, so and the time he takes to finish 100% of the work is 6 hours, whereas for B it's 8 hours, and whereas for C it is 15 hours, and each one finish 100% of the work. You just need to calculate. Now LCM of the time, LCM of the duration should be considered as the number of units of work. So the LCM of 6, 8, 15 should be a fairly a simple one. We need not really calculate it. It's going to be very simple. That's going to be 120 units. So the total work is 120 units. Now between that efficiency of A is 20 units, efficiency of B is 15 units, efficiency of C is 8 units. So we distribute the amount in the ratio of their efficiencies, that is 20 is to 15 is to 8. Now we can distribute the amount, that is 94.60 in the ratio 20 is to 15 is to 8. We can do it quite easily. So whenever we come to know that individuals finish 100% of the work, then the total work in terms of the number of units is simply the LCM of the time taken to finish 100% of work. Let's solve question number 2. 3 machines ABC can be used to produce a product. Machine A will take 60 hours to produce 1,000,000 units. Machine B is twice as fast as machine A. Machine C will take the same amount of the time to produce 1,000,000 units as A and B running together. How much time will be required to produce 1,000,000 units if all the 3 machines use it simultaneously? Look, a million units. In place of million units, you can take 100 units, you can take 2 units, you can take 1 unit. So you can replace the million units and take the same units for every single mission. So the target is to produce 1,000,000 units. Now you can revise the target and you can say The target is to produce X units. Now this must be very simple. Here also what is clearly given is like mission A, mission B, mission C, and mission A takes exactly 60 hours to finish 100% of the work. Mission B is twice as efficient. So if the efficiency of mission A is 1 unit, then you can say the mission B is 2 units. Then you can say that the time it takes for B to finish is going to be half of the time of A, that is 30 hours. Yeah, so they finish 100%. Now C takes the same time as that is taken by A and B together to finish the work. Now it's better if we know the number of units of the work. Actually that's 1 million, but we should take a number which is convenient for 60 hours and 30 hours. That's the time. So the LCM of 60 and 30 is 60. So you can say that the number of units of work is a multiple of 60. You need not take 60 actually. So it could be like 60 units, 60k units. Now, since the efficiency of both A and B is or 1 and 2, so the combined efficiency is 3. So it means to complete the work when they work together is 60 by efficiency, total work by total efficiency. So that is 60 by 1 plus 2, that is 20. So it means that C will take 20 hours to finish. So it means the C capacity is 3 units. When all work together, that is A plus B plus C, their efficiency is obviously 1 plus 2 plus 3, which is 6. And we know that the total work is 60k units. So total work by total efficiency, that's supposed to be 10 hours. Very easy, very simple. Walford got an order from a garment manufacturer for 480 denim shirts. He bought 12 sewing machines and appointed some expert stylers to do the job. Now, I suggest you not to read the next statement and try to understand the statement that we have read. It is 400 denim shirts, that's one information. 12 sewing machines is also one information. But what you need to observe closely is some experts. Some could be exactly 12 or must be less than 12. Because only 12 people can work. However, many did not report to work. As a result, each of those who did had to stitch 32 more shirts than originally planned by Alford, with equal distribution of work. How many tailors had been appointed earlier? How many had not reported to work? So we know that we can easily say a maximum is 12. So it could be 12, 11, 10, any number. And each one produces the same number. That's X. Because some of them were absent, they had to produce X plus 32. It's very easy. Now, either you can go through the answer options or you can take some variables and solve. I suggest you to go through the answer options, even though one of the answer options carries none of these. It must be fairly simple to solve this question if you go through answer options. Now, if you have 12, absolutely this one. If 12 people originally, then each one 40. Since each one has to do 32 extra, now 72, and then 4 absentees means it means 8 must have presented. So 8 into 72, that crosses 480. So that's not possible. Now you can take 10 actually. So if there are 10 actually, each one should be doing 48. Now 48 plus 32 is each one must be doing 8. If each one is doing 8, then we just need only 6 people. However, it mentioned that it's 7 presented. That's ruled out. Now this one should be correct. Since we have already done it for answer option A, we can easily say that it's answer option C. Or else you can say n people initially, each one is doing X units. Then some people are not presented. So in place of n, you can take some other variable, and then it's X plus 32. So we are taking more number of variables. That leads to a bit of complexity. That's why I suggested you to go through the answer options, because it's a very small number, right? 480. Yeah. Let's move to next question. A group of workers was put on a job. From the second day onwards, one worker was withdrawn each day. The job was finished when the last worker was withdrawn. Had no worker been withdrawn at any stage, the group would have finished the job in two-thirds the time. How many workers were there in the group? It's just a condition based. It must be fairly simple. Mistake. So number of persons. So we have no idea their capacity or their efficiency. We certainly have no idea. The time taken, no idea. So then it's total work. Yeah. Look at this one. A group of workers. So it's N. And we have no idea about the capacity also. The time taken by them to finish. We just have no idea. So if we say that the time taken by all of them to finish the work is, let's say, 2x. I've taken not x, actually I've taken 2x, by keeping in mind that if all of them work, they finish the work in the same time, that is two-thirds of the original time. Let's take two-thirds of the original time. Let's take, this is 3x time. So original time, let's take, I'm trying to give you some variable. Okay, instead of it, actually you can just say n, and then time taken by them to finish is two-thirds of the original time, two-thirds of x actually. Then you can say x is the original time. If one person is first person is n persons, the next day it's n minus 1, next day it's n minus 2, and so on. What can we do here? When the last worker is withdrawn, it means that at the end there was only one worker, so it's like one worker. So it means on day 1, if we think that the efficiency of each candidate is 1 unit per day, then you can say on the day 1, n people must have produced n units. On day 2, they must have produced n minus 1 units. On day 3, they must have produced n minus 2 units, like this. So it is n plus 1, n minus 1, n minus 2, n minus 3. So the sum of this is like sigma n. Sigma n is nothing but n into n plus 1 by 2. These are the total number of units. So this we can say this is the total number of units. Now that must be equal to the total number of units done when all the people presented every single day. That's going to be n into 2 by 3x. So once we compare these two, that's going to be fairly simple. It's just down. So in x hours, they've done it n into n plus 1 by 2. So it must be fairly a simple one. It's just a comparison. Now once we solve these two, then we'll get the answer quite easily. Let's solve question number 5. There's a leak in the bottom of the tank. This leak can empty a full tank in 8 hours. When the tank is full, a tap is opened into the tank which admits 6 liters per hour, and the tank is now emptied in 12 hours. What is the capacity of the tank? Look, we can solve this question in two different ways. One, we can use percentages, and the other one is like a simple product consistency method. Now look at this one. We know the inlet pipe capacity, that is 6 liters an hour. We have no idea about outlet. Absolutely, this question mark. Now however, outlet takes 8 hours to complete it, means that in 8 hours it finishes its complete job. It means 100%. And now what really happened? The inlet pipe, that is, it's doing positive work, and the outlet pipe it's doing negative work. Both of them were in operation. Now what happens is the inlet pipe, what it do is like it is 12 into 6 liters per hour. That's what it pumps in. And the outlet pipe, what does it do? It drains out all the water. So in 8 hours, if it can do 100% of the work, then in 12 hours, so obviously it's going to do 150% of the total capacity of the tank. Where is this 50 extra percent? 50 extra percentage is directly coming from the inlet pipe. Normally, the outlet pipe finishes the work in 8 hours. That is, it completely drains out entire capacity of the tank. Since it's working more than 8 hours, it means there has to be some inflow. Now, the entire inflow is for 12 hours. To finish the entire inflow of 12 hours, so outlet pipe is taking only 4 hours to do it actually. So in 12 hours, it pumps in 72 liters. That is equal to 50% of the capacity of the tank. 50% of the capacity of the tank. So if 72 liters is the 50% of the capacity of the tank, then 100% capacity is going to be 144. So it means that the method that we use to solve this question need not be a method that is related to time and work actually. We can use percentages also. What else we can do by taking the capacity of the outlet pipe as X liters, then it finishes the job in 8 hours, 8x liters, 8x liters, and then we can similarly focus on it also. That's it. Let's move to next question. One man can do as much work in 1 day as a woman can do in 2 days. A child does 1/3 the work in a day as a woman. If an estate owner hires 32 pairs of hands, that's men, women, and children, in the ratio of 6:5:2, and pays them in all rupees 1113 at the end of the day's work, what must be the daily wage of a child be if the wages are proportional to the amount of the work done? This must be a fairly simple question. If you know how to solve it, it won't take more than 30 seconds to solve. Now, we just need to compare the efficiency of persons. We give the salary only based on their efficiency. Now, what is the efficiency of a man to woman? One man can do as much work in 1 day as a woman can do in 2 days. So, if a woman works for 2 days, she would be able to finish the work done by a man in 1 hour, one day. So that means that man to woman, the efficiency is 2 to 1. It's 1 day. If he's finishing 2 units, then a woman needs 2 days. So it means that the efficiency is 2 and 1. This is efficiency. Now, let's compare a child. Child does 1/3 the work in a day as a woman. A woman, the 1 day capacity is 1 unit. So for a child, it should be 1/3 of women. So that's 1/3. You can keep the ratio as 2:1 is to 1/3, or else you can convert them. Instead of a fraction, you can write the efficiency as an integer. So you can say that this is going to be, let's say this is going to be 3, this is going to be 1 actually, then this is going to be 3, and this is going to be 6. So the efficiency of a man per day is 6 units, efficiency of a woman is 3 units, efficiency of a child is 1 unit. That's 1 day efficiency. Now can we distribute the amount in terms of 6:3:1? No, it's not possible. Can we do it? No, we can't. Why we can't is quite simple. It's efficiency of a man women and then child is known. But how many people are working? How many men are working? We distribute the amount in the same ratio as that of the total work committed by men, women, and child. It's not just based on their efficiencies. It must be based on the number of days they work, or it must be based on the total number of persons working actually. Now, so they have taken 39 pairs of the hands in the ratio 6 is to 5 is to 2. So we have 39 pairs. It means that 39 persons, and it must be distributed in 6 is to 5 is to 2 ratio. It's man, women, and child. In such a case, 39 could be divided, and then this is going to be 18 men, 15 women, and 6 children must be working. Yeah, it's 18, 15, and 6. Now it must be very easy. If 18 people are working and each person can do 6 units of work, then in such a case, all of them together, they finish 108 units of work. This people is doing 45 units of work and they're doing 6 units of work. Now the amount can be distributed in the ratio of 108 is to 48 is to 6. And then we just need to find the average earning of a child. So we can say child gets 6 parts out of 159 parts. That's 42 rupees. This is all the children together, they get 42 rupees. How many children? 6. So we need to find the average earning of a child. So we need to find the total earning divided by, it must be distributed among all the children. Since we know that the number of children available are 6. So 42 by 6. What we have done is quite simple actually. This question, we have used a lot of ratio concepts rather than using time and work. But however, we need efficiency, we need the number of people working. Once we know the efficiency of individual persons and we know how many men, women, and children are working, then we can distribute the amount in the same ratio as the number of units finished by man is to women is to children. Once we know, then we can redistribute. Let's move on and solve the next question. A group of men decided to do a job in 8 days. But since 10 men dropped out every day, the job got complicated at the end of the 12th day. How many men were there at the beginning? This must be a simple question. So if there are n men, each one is finishing 1 unit a day, they need 8 days to finish the work. It means that the total capacity, the total work is 8 units, which is 100%. What can we do is, but 10 men drop out every day. It means that on day 1, n people, and each one is completing the 1 unit, and it's 1 day work. So it means that they finish n units. Whereas on day 2, 10 people drop out, that is, so in the same 1 day, they finish n minus 10 units. Like this, the work completed at the end of the 12th day. So every day, they do 10 units less work. So first day n, second day n minus 10, third day n minus 20, fourth day, fifth day, sixth day, seventh day, 11th, and 12th day, like n minus 110 people presented. So they finish n minus 110 units. So instead of trying to add n minus 10, n minus 20, n minus 30, n minus 40, since the numbers are in arithmetic progression, we can take first term plus last term, that is n minus 110 by 2 into number of terms, that's 12. That must be equal to 8n. So 8n is equal to 2n minus 110 into 6. So that's finding n is a very simple task. Now, let's solve. We have solved this question already. While going through the concept questions, we have already solved this question. Now, A can complete a piece of work in 4 days. B takes double the time taken by A. C takes double the time that of B, and D takes double the time that of C to complete the same task. They are paired in a groups of 2 each. One pair takes 2/3 the time needed by the second pair to complete the work. Which is the first pair? Now, A finished the work in 4 days. B double time, it's 8 days. C again double time, that's 16 days. D double time, that's 32 days. But do remember, all of them, each one is finishing 100% of the work. If each one is finishing 100% of the work in terms of the number of units is equal to the LCM of the number of days taken by them. That is going to be 4, 8, 16, 32. LCM is going to be 32. So that is LCM of 4, 8, 16, 32. That is 32. Now we can say that the total work is that 100% of the work is equal to 32 units. Now based on it we can say efficiency. Now A takes 4 days to finish 32 units. Each day it's 8 units. Then B must be 4 units. C must be 2 units. And then D is 1 unit. That's the efficiency. Now one pair takes 2/3 the time needed by the second pair. So just first pair and second pair. Now we can take AB. If AB is finishing, if AB is working together, then A and B, they together finish. The capacity is 12 units efficiency. So to finish 32 units, and then other pair is like CD pair, their efficiency is 3 units. So if the time is inversely proportional to efficiency, that's going to be 12 units and 3, that's then its reverse is 1:4. Then it's not 1/3. Then A and C working together, they finish 10 units. Then the remaining pair, that is BD will finish 5 units. So this is B plus D. So efficiency is in the ratio 2:1. Then time is in the ratio reciprocal of it, 1:2. That's ruled out. And if B and C are working, if BC, they do 6 units. Then the remaining pair, that is AD, they finish 9. That's going to be 9 A plus D actually. Now the efficiency is in the ratio 2:3, so time would be in the ratio 3:2. In such a case, the same thing, it's 2/3 the time. Which is the first pair? First pair, carefully here. First pair takes the less time. So the first pair is A plus D. It's not B plus C. So A plus D. B plus C, they finish 6 units of work, and A plus D is finishing 9 units of the work. So that's A plus D. Let's solve 9th question. A company has a job to prepare certain number of cans, and there are 3 machines A, B, C for this job. A can complete the job in 3 days, B can complete the job in 4, C can complete the job in 6 days. How many days will the company take to complete the job if all the machines are used simultaneously? This must be the easiest time and distance question ever asked in CAT. A take 3 days, B take 4 days, C 6 days. Should I explain it actually? So they finish 100% of the work. So the LCM of 3, 4, 6, that's 12, is the total work in terms of the units. Now the efficiency of each one is, since each one is finishing 100%, efficiency of A is 4 units per hour or per day, B is 3 units, then C is 2 units. So the total efficiency is 9 units, the total work is 12 units. So total efficiency of ABC together per day is 9 units. However, the total work is 12. So 12 by 9 time is total work by efficiency. Let's move. The last but one question. Three small pumps and a large pump are filling a tank. Each of the three small pumps works at two-thirds the rate of the large pump. What is the rate? The rate is nothing but the efficiency. So three small pumps, efficiency we can say, and one large. So efficiency we can say it's clearly given two-thirds rate. It means that if it is like 3 units, then each one is doing 2 units. If all the 4 pumps work at the same time, then they should fill the tank in what fraction of the time that it would have taken the large pump alone. Now, we have no idea about the time it takes for large pump to fill. Should we know? Should we really know how many hours? No, it need not be. You can simply take that. That's going to be fairly simple. One large pump, it fills 3 units in 1 hour. We can directly say that the total capacity, which is 100%, itself is equal to 3 units. Exactly. So it means to finish 3 units, it's taking 1 hour. Now, if all the 4 pumps are working, exactly. So it means per hour capacity of 3 small pumps is 2 units. It means together they finish 6 units in 1 hour. So 1 hour they finish 6 units. 1 hour large pump finish 3 units. So it means 1 hour together capacity is 9 units in 1 hour. Now the total capacity of the tank is 3 units. The combined capacity of all the 4 pipes is 9 units. So the time is total capacity by the total tank capacity by total efficiency of all the pipes, that is 3 by 9. So it takes 1/3 of an hour. 1/3 hour. So large pump takes 1 hour. So small pump takes 1/3 an hour. All the pumps together they take 1/3 an hour. So this must be a very easy question. So last question. It takes 6 technicians, a total of 10 hours to build a new server from direct computer, with each working at the same rate. Very good. Each working at the same rate. So the efficiency of each worker is same. So we have got 6 technicians. Their efficiency is, let's say, 1 unit. They take 10 hours. So the time is also given 10 hours. Now we can easily say 6 technicians, each technician 1 unit in 10 hours, each technician finish 10 units. So total 6 technicians. So that is 60 units, which is 100% of the work. If 6 technicians start to build the server at 11 a.m. and 1 technician per hour is added beginning at 5 p.m. So they started the work at 11 a.m. and 1 worker is added every hour starting from 5. So from 11 a.m. to 5 p.m. only 6 technicians. So it means 6 hours. So in 6 hours, 6 technicians finish 36 units. And at 5 to 6, 5 p.m. to 6 p.m., we have got 7 technicians. Each one is doing 1 unit. That's 1 hour. They'll finish 7 units. In the next hour, that is 6 to 7 p.m., we need to add 8. So each one is, that's 8 units. So that is 36 plus 7 plus 8, and plus it's going to be, if they want to do next time, if the work is not finished, next it's going to be 9, and so on, like this, if until the work is finished. But by this time, that is 36 plus 7 plus 8 plus 9, that itself is 60 units. So the 60 units of the work is finished when the 9th person joined and he finished his task actually. That's like 9th person joins at 7 o'clock and he works 7 to 8 o'clock. That's it. So we have solved all the questions, all the 11 questions, but the level of difficulty of all these questions is very limited. Let's check when they appeared. The question number 1 appeared in 1990. Question number 2 and 3, they're directly from 1991 papers. Question number 4 is from 1993. 5 is 1994. 6 and 7 are from 1995. 8 is from 1998. 9, the easiest one, is 2001. 10 and 11 are from 2002 and 2002 actually. Why we don't have a very easy question in the last 2014 or 13 is fairly simple. The total number of arithmetic questions is asked is always 20%, approximately 20%. So from 2009 to 2013, the total quant questions were 20 questions. So out of the 20 questions, 20% itself is 4 actually. And the arithmetic and the time and work weightage within arithmetic is just 10%. So arithmetic itself is 20% of the total weightage of quant, and arithmetic is 10%. That's going to be only 2% weightage. 2% weightage out of 20 questions is like 0.4 questions. That is why we had a maximum of 1 question in the last 4-5 every year maximum, or 0 questions asked from time and work. And if at all they have asked, actually it might not be easy question, it may be moderate question, or they might not have asked it actually, because time and work is not at all a difficult one. It's just like application of product constancy. Anyhow, in the next video we will solve all those difficult moderate questions. In fact, there are exactly 3 moderate questions. We have solved 11 easy questions in this video, and 3 are going to come in the next video. That's moderate level. That's 14 questions. However, 19 questions are asked in CAT, and the remaining 5 questions I ignored because all those 5 questions are relatively very simpler. Thank you, and do watch the next video.